You've surely seen these photos. These are some of the most iconic photos ever taken, defining the history of the United States in 1969. They are from the Apollo 11 mission, where Buzz Aldrin, Neil Armstrong, and Michael Collins landed on the moon. But there's something peculiar, something is missing in all these photos. In fact, it's absent in almost all photos and videos ever taken in space. Where are the stars? Is this evidence of a conspiracy that has been in front of our eyes all along, or is there a more reasonable explanation? So today, we'll answer the question, why can't we see stars in space? Most cameras have worked the same way since 1969. We still have things like aperture, shutter speed, ISO, a shutter button, among other things. And, of course, things have been updated, but when taking a photo, light still enters a sensor, and all that information is interpreted as a series of ones and zeros to create an image or is printed on a film negative. Regardless of the process used to create the photo. Every camera, whether it's a relic from 1969 or a recent innovation, is a master at one thing, the art of capturing light using the three variables of the so-called exposure triangle. Manipulating these three variables essentially determines whether the image will be too dark, too blown out, or if it will be perfect. That's incredible, you're right. So, what does all this have to do with why stars don't appear in photos taken in space?
Hippity hoppity, hippity hoppity, hippity hopping over hill and dale.
Let's take a look at this photo of Buzz Aldrin next to the American flag. Because there's no atmosphere on the moon, there's nothing to scatter sunlight. And if you notice, both the lunar surface and the astronaut suits are highly reflective. Neil Armstrong, who took this photo, had to expose for the most reflective parts of the image. So, anything less reflective appears much darker in the image, like the lunar module and the starry sky. If he had exposed this photo for the night sky, everything else in the photo would look something like this. If they wanted to take this photo, they would have to take two different shots with different exposures and merge them, probably placing the camera on a tripod, something they didn't have the time or weight capacity to do.
2, 1, 0, all engine running.
Now you know why stars are absent in photos. But why are they also absent in videos? Well, actually, you would have much more difficulty capturing starlight points on a video camera than on a still camera in space, whether the camera is from 1969 or 1984. This is astronaut Bruce McCandless. He had the undoubtedly challenging and objectively terrifying task of testing NASA's Manned Maneuvering Unit. It was a nitrogen-powered jet thruster designed for untethered spacewalks, so astronauts could have more ease working outside the spacecraft. When he used the unit to fly about 100 meters away from the spacecraft, again, the same problem. All you can capture is a pitch-black sky. So, neither photo nor video is ideal for capturing starlight in these scenarios. Even though both Bruce and the Earth take up less space in the frame than the Moon in the last photo, they are still the brightest objects in the image. Exposing for these bright objects, no matter how large or small, will affect the exposure of the entire image. And remember that the entire purpose of these photos and videos taken in space is to document what the astronauts and instruments are doing, not what space is doing. So, while all this explains why stars cannot be seen in photos or videos, there's still a very significant problem to solve.
When you looked up at the sky, could you actually see the stars and the solar corona in spite of the glare?
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics.
There are countless examples of astronauts and civilians who have been in space, and they all say the same thing. When they looked into the vastness of the universe, where they expected to see their vision bathed in the infinite beauty of the cosmos, they were met with a beautiful view of nothingness. In the example of the Apollo 11 team recounting how they couldn't see stars from the lunar surface, this understandably left the public a bit uneasy and suspicious, leading to the moon landing hoax conspiracy that persists to this day. And I mean, they were on the moon. There was absolutely no atmosphere to prevent them from seeing starlight. If humans ever had a better chance of seeing the universe the same way something like the Hubble shows us, this was clearly the best chance. But still, nothing. However, there was one place that both Buzz Aldrin and Neil Armstrong recalled being able to see stars from the lunar surface, and it was right here in the shadow of the lunar module. When they stood there and looked up over a few minutes, the universe and the stars began to reveal themselves. And the concept of this is not particularly hard to understand. You've experienced this before. In fact, you can demonstrate this concept at home. All you need to do is enter a dark room, sit for a minute, let your eyes adjust to the darkness, and then turn on a flashlight. When you aim this light at your eye, the rest of the room behind the light suddenly becomes completely black. And this happens because our eyes, kind of like a camera, automatically adjust to expose for the brightest object within their field of view. And the exact same thing happens to astronauts on the International Space Station when they are on the illuminated side of the Earth. The brightness of both the Earth and the lights inside the ISS is enough to make their pupils shrink, not allowing enough starlight to be detected by their eyes. However, when the ISS reaches the nighttime side of the Earth, where they don't have the sun's brightness to contend with, and they can go to an observation deck away from the most possible onboard light, like Aldrin and Armstrong, they too can have an incredible view of the cosmos. So, depending on where you are in space, where you're looking, and how much light you're exposed to, it completely changes how you capture and see the universe. The best way we have to photograph stars in our galaxy and the universe is telescopes, both on Earth and in space. They can hold a position at a specific point in space for long periods, with their sensors fully exposed, allowing as much light as possible into the telescope to produce incredible images like this. So, when it comes to capturing and visualizing the stars above us with a handheld camera or our eyes, we are limited by the constraints of our own technology and biology. But maybe one day, in the near future, space travel becomes much more accessible to the average person, true space tourism where we could not only touch the edge of space but have the opportunity to take a complete orbit around the planet. And if you're one of the lucky people who get to experience this in your lifetime, I can only imagine the transformative view of the universe you would have when reaching the dark side of the Earth.